galaxy is basically a star-forming factory, and that's sort of what a galaxy does. Like the Milky Way galaxy, the one that we live in, is forming a lot of stars, and that makes it it's active in that sense. A dead disk galaxy. It's a galaxy that's both disk-shaped, but it's dead in the sense that it doesn't have a lot of star formation going on. So when you see a galaxy that is dead, it tends to be what's called an elliptical galaxy. So kind of elliptical in shape, lots of stars kind of buzzing around the center in sort of random directions. Whereas if you see a galaxy that's alive, that's forming stars, it tends to be a disk. But this galaxy kind of mixes both. It's both disk-like, but also dead. It was found behind a cluster of more nearby galaxies. To form a star, you basically need a lot of gas that is cold enough and dense enough to start collapsing under its own gravity. And as it does so, it starts to sort of fragment into little lumps. Each one of those lumps can collapse further and heat up as it does so. And if it gets hot enough, eventually it can start fusing hydrogen into helium, and that's when the star is actually born. So what could have turned it off in this case? It could be basically you have to sort of starve the galaxy of cold gas. Galaxies have a black hole in their center, a supermassive black hole, and those black holes actually drive material out. They have outflows, and that could be one way of getting gas out of the galaxy, preventing it from forming stars. It could also be that this galaxy is just getting so massive that as cold gas tries to come in, it basically gets shock heated, so that it can't actually cool down enough to form stars. It's about 3 times the mass of the Milky Way, but it's much more compact. It's about half the size. We had this picture that, when you've turned off star formation in a galaxy, it should look a certain way. It should look like an elliptical with stars buzzing around, and that's not true in this galaxy. So there's some nuance that we don't quite understand, and so to feel like we understand how galaxies form, we have to get that right. The ideal thing would be to find more galaxies like this one to sort of get a sense of whether this is an oddball or representative of galaxies at that time in the universe's history. So that's sort of the next step, is to just find more of them and characterize both their shape, see how many are disks, and also show what their motions are like. Are they rotating very quickly like this one is?
Eye on Research is a production of New Mexico State University.